Talk about rotations and reflections and what that does to sines, cosines, and tangents. And it's going to take me a while to get through this. Like I said, I don't think I'll finish it, but we'll see how far we can get. So let's label this as triangle 1. And we'll call this triangle 2. And I know right now you have these symbols, but I'm going to call this angle 1. And I'm going to erase that here in a moment. Call this angle 2. And this is angle 3. And then this will be angle 4. So the idea here is that we start with a rotation. So we're going to start with theta. So theta is what angle 1 is worth. Okay, and that gives me this situation here. So I'm at this point with that x and that y. And I could find sines and cosines and tangents. Okay, now I want to see what happens if I rotate around the origin by 90 degrees. So if I add another 90 to it, then from angle 1 I end up at angle 3. Does that make sense? So theta plus 90 represents from here to there. Now the first thing that we need to do is we need to sort of be able to prove that this is indeed true, that that's x and that's y, and that this coordinate here is a negative yx. So that means that I need to be able to, you need to be able to tell me why triangle 1 is congruent to triangle 2. So is there anybody that knows how to do that? I'm sure a couple of you can. So how can I prove that angle or triangle 1 is congruent to triangle 2? Anybody? Okay. In triangle 1, what do angles 1 and 2 add up to? Angle 1 and 2 adds up to 90. Okay. What do angles 1, 90, and 3 add up to?
180.
180. So we know that 180 is equal to angles 1 plus 90 plus 3, right? Subtract 90 on both sides, so that means that 90 is equal to angles 1 plus 3. And since both of these add up to 90, we know that 1 plus 3 is the same as 1 plus 2, so 3 must equal 2. So that means that, and I'm going to erase this a little bit, that means that angle 3 is the same angle as angle 2. Are you guys okay with that? So I'm going to erase that. So that's why we had double tick marks there. And that means that angle 1 also must be up here. So that's why we have theta here and theta there. And so you can prove that these triangles are congruent. Okay? Is everybody okay with that little proof? I'm sorry? What did you say? Yes. I mean, well, since 3 and 2 have to be the same, that means that the third angle has to be the same as well, right? Okay? Because we have a right angle here, so we already knew that they did share a 90 degree. Okay, that also means that from here to here, that ends up being the same as from here to here, right? So that's why this x is also over here. And I know I usually mark that as a y value. We're just trying to show you that, you know, if this distance was 4, then so would this distance be 4. That's what we're trying to see. Okay? Alright. So now I'm actually going to look in triangle 2. So in triangle 2, what would be the sine in this triangle? And that would be, actually, we would write that as the sine of theta plus 90. So theta plus 90 is from here to here, right? And in our last section, we discussed that if you rotate past 90, then to find the sine, you would look in this reference angle here, right? So this becomes your reference angle. And your sine would be what? What's the definition for our sine, usually, in triangles? Okay, so what is the opposite and what is the hypotenuse? The opposite here is? X. And the hypotenuse is? They labeled it R. Why do you guys think I use R all the time on the board for the bell work, right? That's an R, yes? Okay. Well, so this was in triangle 2. So in triangle 1, x over r is represented by what ratio? X over r is actually it's a cosine. So doesn't that mean then that the cosine of theta has to be equal to the sine of theta plus 90? You guys sort of see that this has to be true? It means the following. If I told you that the cosine of theta, if I said, well, if theta is 20 degrees, then the cosine of theta would be, and actually I'm going to put it in so I don't lie right now. So what's the cosine of 20 degrees? 0.94. That's my marker. So that means that the cosine of 20 degrees is 0.94. If you know this is true, then you also know that the sine of theta plus 90 has to be the same value. So this becomes the sine of 20 plus 90. What's 20 plus 90? 20 plus 90 is? So the sine of 110 degrees will also be 0.94. And if you had a calculator, you could double check that, which I'm doing right now. And it gives me exactly the same answer. Okay? So that's what that rule says. Take any angle, find the cosine, and that value, whatever you get there, that will be the same as if you added 90 to it and found the sine of it. Are you guys okay with that? Alright, let's go look at my cosine then. So what's the cosine of theta plus 90? Thank you. So again, I'm over here in this reference angle. The cosine is usually our adjacent side divided by the hypotenuse, right? So the cosine is y over r. With one minor little detail. This y needs to be a negative, doesn't it? Because the distance from here to here, I'm sorry, if I'm moving from the origin out to the left, then this is a negative value, isn't it? Yes? Okay. What ratio is y over r in the first triangle? What the ratio y over r is what value or what trig function? Let's say in the first triangle y over r is our, come on guys, I'm doing y over r. That would be the sine. But that says a negative y, so I'm just going to do this. Make that a negative sign, then I can make this a negative y over r. So that means that the cosine of theta plus 90 is equal to the opposite of the sine of the original angle. Yeah. No, that would be a negative 1 times sine. What you just said, sine negative 1 of something, of an x, that's inverse sine, right? This is an inverse sine. That's not the same thing. I said a negative 1 times sine. Yeah? This is a completely different negative 1. Well, yeah, but that's called an inverse sine. That would be when you know what the ratio is, you throw it in the calculator and then it gives you the angle that goes with it. Alright, last one then is the tangent. So what's the tangent in theta plus 90? So in the second triangle, the tangent is opposite, right? Which is your x divided by your y, but that's a negative y. And so what in triangle 1, x over y represents what? X would be adjacent over opposite. Adjacent over opposite is a, not the tangent, but you need to flip it, right? So it's your cotangent. Good. But I need it to be a negative, so I'm just going to multiply here by a negative to make this a negative x over y. So that means that a negative cotangent is the same. So take the opposite of the cotangent. That would be the same as finding the tangent of theta plus 90. You guys okay with this mess? Alright, so here are 3 things that you sort of need to have memorized. I say sort of because you can either have it memorized or you can do basically the same thing that I did earlier in the bell work today, and that is sort of know how you can come up with it. And I know how to come up with it when it's in context of a problem. And it's actually, you know, both of them have their uses. So in this case, it wouldn't be a bad thing if you had this memorized. Okay. I'm going to move on then, and then we're going to look at what happens if we rotated the angle 90 degrees in the clockwise direction. Okay, so clockwise would mean that again, if we started with the original position, so if you start with theta, if you go clockwise, that means you're going this way, right? Yes? No? Okay. But because we didn't define theta in one way or another, whatever we just had works for any angle. So what we're going to do is, for example, I'm going to look at the first, if I look at the first rule, so the first rule was what? That the sine of theta plus 90 was what? That was equal to the cosine of theta, right? Okay, wherever it says theta, I'm going to replace that with theta minus 90, because this rule works for any rotation. So I'll just replace. So theta is now going to be written as theta minus 90. It's just a new theta. And then we still need to add 90 in this one. And on this one, we end up with theta minus 90. And how much is a negative 90 plus 90? 0. So it means you get the following relationship. It means that the cosine of theta minus 90 would be the sine of theta. So that's the difference of theta and 90. And the first one here, it was theta plus 90. And they're not the same, are they? Right? Because we are at cosine theta minus 90, that's the sine, and here the cosine of theta plus 90 is a negative sine. So you can do that for the second one as well. So the second property, or the second identity that we sort of looked at, was that the cosine of theta plus 90 was equal to what? Theta plus 90 was a negative sine, right? Yes? Okay, so replace theta with theta minus 90. So you get a negative sine of theta minus 90. These two cancel again. So on this one you would get the cosine of theta is the opposite of sine theta minus 90. But we want to write them all like this. So we want to have a positive there. So this negative, I can just move it to the other side, right? I can write this and that would be the same. And this is sort of what we want to have in terms of memory. If you want to put anything in memory, it would be this one. It would be sine theta minus 90 is the opposite of the cosine. Okay, then the third rule doesn't quite work the same way, so this one I'm just going to throw out there. And that would be that the tangent of theta minus 90 is a negative cotangent of theta. It does start the same way just by replacing it, but then you got to do a couple other things. So you guys okay with that one? So this one's just using what I showed you on the first one, plugging in a theta minus 90 and working your way through it to make it look pretty again. So that was either adding or subtracting to it, right? So that was either adding 90 or subtracting 90. Well, we can also rotate by 180 degrees. So what happens if you rotate by 180? It's actually a lot easier. So let's assume you started over here. If I rotate 180, so if I rotate theta plus 180 this way, I end up over here, right? Yeah? What happens if I start at theta and I rotate a negative 180? I would end up over here as well. So the plus and minus is explained pretty easily because 180 twice is 360, so you add up in the same spot. Either you by adding or subtracting 180, you're going to end up halfway through one rotation. That means that if you started out from here to here with that x and that y, when you rotate it, you end up over here. And actually, I think this one, and I'll make it solid, but they have it dotted so that you can see that it's a different line. Are you guys okay with the second location then? Well, if from here to here is x, then from here to here must be a negative x, right? And if from here to here is y, then from here to here must be a negative y. So that's where the negative x and the negative y come from. And that's pretty much all I really need, because now I can look at, and I'll look at the first one first. So I'm at the original spot. Oh, I don't know what I just did. So let's look at just the sine of theta. The sine of theta would be y over r again, right? And then over here, what is the sine of either theta plus or minus 180? What would it be here? So now you're over here, and you're looking here. Where will you be? What will the sine be? Yeah, because that's a negative y, so that's a negative y over r. So what can you say then about the sine of theta compared to the sine of theta plus or minus 180? Well, they're opposites. How about the cosine? Well, the cosine is basically the same story, but on this side it's x over r, and on this side, when you do theta plus or minus 180, you get a negative x over r. So that means that this is also true for the cosine. So these two work pretty well the way you'd like them to. But the tangent's a little bit different, because what happens with the tangent? It's y over x. That's our normal definition for the tangent. What happens over here when you do the tangent? When you do plus or minus 180? You end up with a negative y divided by a, the x is, from here to here was how much? Guys, what's this? From here to here is how much? What is this distance from here to here? It's a negative x. Okay, it's right here. And a negative y divided by negative x is the same as, so the tangent of theta is exactly the same as the tangent of theta plus or minus 180. Okay, so then you end up with those three rules. Okay, the second picture is here just to sort of show that it doesn't matter where you start. I mean, if you started in this quadrant and you do 180, it works the same way. So I don't want to prove that. It's the same idea. I do want to finish with this one over here. So a reflection is when you have a mirror image. So what we're going to do is we're going to mirror this angle, this theta over here and over here. So if this theta is positive, then this theta is negative. Okay. So this distance here is y, right? And this one is x. What's this distance from here to here? That should be a negative y, shouldn't it? So again, let's look at the sine for the original one. So the sine of theta originally is y over r. What's the sine of a negative theta then? When you rotate in the negative direction, you end up with negative y over r. So the sine of a negative theta is the opposite of the sine of theta. Okay, if you had to memorize any of these would be the ones to memorize. Right, Steele? Yeah. How about your cosine? The cosine is x over r. What happens when you rotate in the negative direction? Does your x change at all? Or are we still from here to here? Okay, so that's still x over r. So the cosine of a negative angle is exactly the same as the cosine of the positive angle. How about your tangent? Originally the tangent in the first one is y over x. So if you make that a negative rotation, which one of these changes to a negative? The y does change. The x does not change to a negative, does it? Okay, so that means that you get the opposite here again. Okay. Out of the ones that I've sort of proven, I would say memorize these. Okay, because this really saves you a good amount of time. All the other ones you can pretty much do with a picture. Okay.